Everyone. Well, I have 12:05 and we have a lot to cover today, so I'm going to go ahead and get started. My name is Derek Harmon, and I'm an associate professor in the Department of Anatomy at the University of California, San Francisco. And we're really excited to have the second iHackHealth Appathon kickoff event today. We have a lot that we want to get to, but the first thing I want to do before we get started is actually just say a big thank you to the whole team that's put this together. It's been a lot in the background that we've been working on for a few months. So thank everyone that has helped from UCSF and UC Berkeley. It couldn't be done without you. So what is the iHackHealth Appathon and why are we doing it again? So this is a project that is near and dear to my heart because my own experience when I was a graduate student, I needed an app developed and I'm not a programmer. So I didn't know where to start. And so I reached out to my alma mater's computer science and engineering department to see if that might be a project that they would be interested in. And luckily I had some undergraduates that thought it was a worthwhile problem. So they teamed up with me and we developed an iPad application to help teach medical students. And so I knew when I came out here to UCSF that I wanted to create something similar because I knew there were ideas in the clinical setting or in research that could help tremendously as an app. And so it took a little bit of time, but I finally found the Fung Institute at UC Berkeley, and Julie McShane and Jennifer Mangold have been instrumental in helping get this together. And if you're not aware of the Fung Institute for Engineering Leadership, they work to help train technical leaders to innovate across boundaries and experiential learning. And you'll hear a little bit more about that group today too. But I think what's really worthwhile for all of you that are from UC Berkeley looking to sign up for some of these projects, what's great is you are actually going to be helping make change in the clinical and research settings with these. Even though we're likely just to get some prototypes, I think the next stages beyond this can be really worthwhile. So we have a lot to cover today, and here is the general schedule. So we're going to go through some logistics about the whole Appathon over the next about 2 weeks. You'll see a video where the UCSF PIs put together 2 to 3 minute elevator pitches of the problems that you've already read in the Google spreadsheet sign up form. And then we have Mark Malone from Apple, who's going to talk about some different development frameworks that might be utilized to help solve these problems. And then what's exciting is in the second hour, we will ask you to join the breakout room with your UCSF PI based on the proposal number that you've signed up for. So look out for the chat too, because you should see a link for the Google Docs spreadsheet so that you can sign up in real time if you haven't yet chosen a team that you want to join. And keep in mind, if you can only sign up for one group, so please make a decision. You can't be on multiple just for the sake of it. And so you can review those now and keep that maybe open as a separate tab as we go through here. If you have any questions as we're going through the event, please feel to type them in the chat, and either one of our co-hosts here can answer them, or they'll bring them to Julie or myself to talk today. So here is the overall schedule for the Appathon event. So today by 5 p.m. is when we want to finalize the teams. So let's say you're here and you have a friend that hasn't even heard about this event, but you thought they'd be really interested. Well, you can send them the Google spreadsheet, and you can send them, we're going to have a recording of this. They can watch the event, but by 5 p.m. we want to have the finalized group so we can get working. Between now and February 2nd, you'll meet with your UCSF PI, and it's up to you as a group with you and your PI how often you want to meet. So the minimum is once a week, but ideally, if you have the time, you can meet multiple times. There will also be iOS Apple office hours on the next 2 Fridays from 12 to 1, where you can bring some of your bigger picture questions that you're having that might revolve around a particular development framework. And someone will have a group from Apple that can help solve some of those problems. And there will also be some Appathon staff office hours where obviously these won't be as technically oriented, but we're there to support you and help you with any bigger questions that you may have. On February 2nd, which is the day before the final event, we're going to ask that you and your group have your final slides, whatever that may be, uploaded to the box folder, which we'll send as we get closer. And then the final event is on February 3rd, where it will also be on Zoom from 5 to 7 p.m. and you'll be presenting to a panel of judges your prototype and how you've come across the development process and where you are closer to solving that problem. So speaking of that final event, we want to give you a little bit more insight about what to expect and what you'll be judged on. So I'm going to pass it over to Julie McShane, who will talk a little bit about the judging criteria.
Hi, everybody. Thank you, Derek. Once again, I'm Julie McShane. I'm the Director of Career Development at the Fung Institute, and I'm very happy to be here today to kick off this exciting event. We thought the first day of the semester was an appropriate start to. What better way to start the semester than teaming up with a cross-disciplinary team from across campus to tackle real-world challenges in the medical community and have a direct impact on people's lives. At the final pitch event on February 3rd, your team will have the opportunity to pitch your solution in front of professionals in the digital health field, including representatives from Apple and KP Digital. Judges from academia will also be on the panel providing feedback on your solution, including Berkeley's Department of Bioengineering. And they will be looking for this criteria. This criteria will also be in our iHackHealth Google resource folder, so you could refer back to it. But I'm going to quickly go through the 5 criteria that the judges will be looking at. So demonstrated consumer need. It says your team articulates societal impact of your solution and the needs of the user. Innovative solution. How unique or novel is your team's design to address the proposal? How impactful is your specific solution to their customer group? Market readiness. How refined is the prototype deliverable? How well does your team solution address the need outlined in the proposal? Effective use of Apple kits. How well does your team implement Apple kits to support the development of the prototype? And overall quality of the presentation. How does your team's presentation come across in terms of public speaking, visual communications, and engagement with the audience? And here is a link. We'll send these slides to you after our kickoff event today. And you can find all this information directly in the Google resource folder. Next, I want to give you an idea of what the final pitch template might look like, so you can keep that in mind. We'll also remind you about this in our weekly communications you'll get from the Appathon staff. But here is a suggested template to keep in mind throughout the build phase. Each pitch is expected to be 5 minutes in duration to present your app prototype. And here is a template that you can use. 1 minute intro slide. So we want to know who you are. What's your project title, your team members, what departments and majors are you from? Tell us about yourself. The problem description. Remember, these judges are not going to be familiar with the problem and the challenge. Give us context. The app demo. So this will be 2 or 3 minutes, probably the bulk of your presentation. And this can look at many different ways as you present it out. You can demo in Xcode, in the Xcode simulator. You can have a video using your app, or you can have slides that resemble more of a storyboard. All are okay. And then we realized it's a 2-week build. So tell us about future iterations. What would you do next if you had more time? And you can spend about a minute telling us about that. These presentations should be done as a team, meaning that both UCSF, PIs, and at least one person from the Berkeley team should be presenting. And again, all slides are due to the box folder by Wednesday, February 2nd at 11:59 p.m. And we look forward to reading all those pitches. So next, the prizes. So many of you are going to have questions about the prizes. So in addition to learning new skills and meeting new people, networking with industry, and having fun while making a difference in people's lives, there are some great prizes. So the winning team will be fast-tracked into UC Berkeley's Skydeck incubator, and also have the opportunity to virtually meet and greet with UCSF's Innovation Hub, special recognition from Apple, and the top 3 winning teams will have gift card prizes in different amounts. So that's something that is very exciting, something to look forward to as you're working throughout the build phase. Feel free to ask any questions. Please drop them in the chat. I know I don't see any questions yet, but feel free to drop questions in the chat. We're happy to answer them. I look forward to watching you all build these exciting apps and prototypes and supporting you throughout the Appathon. Now I'm going to turn it back over to Derek for next steps.
Great, thanks, Julie. So we have a couple next steps, some of them that we've already mentioned, but we just want to reiterate. So again, confirm your team members on your sign-up sheet. So before 5 p.m., but ideally, as you're in your breakout room, you can identify who's on the team and make your final decision which proposal team you want to be a part of. In the Google Sheet, if you saw, we asked for someone to maybe self-identify as the point of contact, or as we'll also refer to maybe as the project manager. This is going to help in a number of ways, but one is it allows the UCSF PI just to have one main person that they're going to speak with on setting up meetings, and if there's any questions, that way they're not juggling 10 plus email threads. If you do need to reserve an Apple Watch or AirPods, you can click on the link that's here, which again, we'll share the slides right after this event, so that you can check one out for testing purposes. And again, during the development phase, look out for weekly email communications from the Fung Fellowship and an Appathon team. Remember, just a quick reminder, we have those Apple Mentor Sessions, office hours on Friday, starting this Friday and the 28th from 12 to 1, which we'll send more information about, as well as the Zoom links for the staff office hours. And then you can always come back to the resource folder if you have any other questions. So before we go to the videos, I think I'll pause. I know, Julie, if there's any questions that we need to address. And none that I'm seeing in the chat. So I think
there's one question in the chat from Cornelius. It said, in the case the app moves forward and is accepted in the Skydeck, for instance, how is IP and equity handled? I don't know if you guys have had experience with that from the previous.
Yeah, that's a really great question. We will probably send up a message in one of the weekly communications about this, just to address it for everybody at large. But yeah, so look out for that. But for now, what we've been told from the UCSF Innovation Group is, because they're still just in the very, very early development stages, is that it's kind of handled and owned by the teams. But we'll provide more information and context there. So look out for that information. Okay, so with that, I'm going to switch my view here to the video and confirm. Jenny, can you give me a thumbs up that you can see this? Thank you.
How does weather impact our health? Wildfires, flooding, heat, cold. Climate change is accelerating the frequency and severity of extreme weather events. We've all seen the San Francisco sky orange from wildfires, and we've all felt the heat. These natural disasters increase emergency department visits, hospitalizations, and premature death. So what can we do to mitigate the health impacts of climate change? Hi, my name is Stefano Leitner, and I am a medical doctor, part of the UCSF Occupational and Environmental Medicine Residency Program and Clinical Informatics Fellowship. Together, we will build Bellwether. Using the native iOS functions of connecting to electronic medical records, we will then use weather forecasting data and machine learning to provide personalized prevention during extreme weather events. Let's walk through a few wireframes. On the left, we see an action score, developed from a weighted algorithm that accounts for known indicators of risk, such as zip code, medications, and pre-existing conditions like asthma, all gathered from HealthKit. This action score will change with the weather. A low action score means low risk, and a higher action score means greater vulnerability to weather and a need to take action. Patients will receive an intervention. For example, here we have an evidence-based recommendation to increase their medication. They can confirm the changes, deny, or even talk with a provider. So, ready to get started? For our team, I have already identified the databases, APIs, cloud service, and even have sample code available to help get the process started. Additionally, we will not be alone in building this climate change tech. We have overwhelming support from experts in environmental medicine, geospatial predictive modeling, and climate health. We all have the time and capacity to work alongside you during the Appathon. Please join me as we build Bellwether. For more information and to view the interactive wireframes, please visit tinyurl.com/letshackhealth.
Hi, everyone. My name is Chris, and I'm a cardiac electrophysiology fellow here at UCSF. And I'm excited to talk to you about my idea called Pulse Check. Wearable technology in 2022 can allow us to measure almost all physical and biological parameters ranging from heart rate, physical activity, oxygen saturation, arrhythmias, and more. Now, of course, my focus of my project is to look at wearable devices as a way to measure heart rate. We know that all these smartwatches and wrist-worn wearables that we use these days use a technology called PPG, or photoplasmography, as a way to record heart rate and pair this information with accelerometers or gyroscopes to measure physical activity. The image on the right here shows how we can use the irregularity in the PPG monitoring as a way to diagnose arrhythmias. And most of these devices will now record heart rate either intermittently, usually every 3 to 5 minutes, but can also be programmed into a workout mode where they're measuring heart rate every few seconds. Now, how can we use this data clinically to diagnose someone with an arrhythmia? Well, this is an example of a case that we had with a patient that had a paroxysmal atrial fibrillation, which is an intermittent arrhythmia that comes from time to time. When they're in a normal rhythm, you can see that their heart rate plateaus nicely when they exercise, but then when they get the arrhythmia, you can see that there's quite a lot of variability or irregularity in their heart rate, telling us that they're in an arrhythmia. Now, this type of technology has been validated by many groups, including Dr. Jeff Tison's group here at UCSF, where they looked at this type of irregularity and trained a deep neural network to diagnose an arrhythmia using the Apple Watch PPG data. Another question that we're often asked is, how accurate are these wearable devices when it comes to monitoring someone's heart rate? And now this is an example of a nice study that was published a few years ago that compared a lot of different wrist-worn wearables from the Fitbit all the way to the Apple Watch. And you can see that the Apple Watch is really the most accurate device. The only other accurate device is the Polar H7, which is a chest strap. And it's important to have an accurate device because we want to have very few spurious or missed diagnoses. Now, this brings me to what my question and what my project is. Now, conventional monitoring devices that were first invented many decades ago were something called the Holter monitor. This was almost a huge device that was worn as a backpack and only provided for 24 hours of monitoring. Now, of course, that has become more miniaturized now, and we have new technologies like the patch monitor, an adhesive device that can be worn for up to 14 to 30 days, but still that doesn't provide for the gold standard of monitoring. The gold standard of monitoring is really continuous monitoring longer than 30 days and perhaps for as long as possible. And I do believe that wearable devices will help us overcome these limitations of our conventional monitoring devices and provide for what is near continuous monitoring for arrhythmias. So what do I envision? I envision that we can use the currently available data that we collect on the Apple Watch, the heart rate data, and transform this into a clinically actionable tool that we can use to advance and improve patient care. We want to design an app that will allow us to download this near continuous heart rate data from the Apple Watch and make it easy to send this data to the clinician for review. We want the app to be able to identify periods of heart rate irregularity that are concerning for arrhythmia and flag these events for review. We also want the app to allow the user to record symptoms. So similar to a patient diary that a lot of these conventional monitors use, we want the app to be able to do that too, and essentially replace those conventional monitors, and ultimately provide for ultra-long near continuous heart rate monitoring superior to a lot of these conventional clinical devices. The bottom right is just an example of what we've already done with this type of app. Our goal with our team is to create an app that is going to replace all these conventional cardiac monitoring devices. And I welcome you to join our team. Thank you.
Hi, my name's Peter, and I'm a neurologist. We'd like to introduce our proposal for an automated stroke app, AIMS, which seeks to save the lives and brain cells of people with strokes. Every 40 seconds in the US, someone has a stroke. When a grandparent like my grandmother had a stroke, the clock started ticking. In the 3 seconds it took me to say that, 96,000 brain cells would have died, and 32,000 brain cells will continue to die each second. The outcome only gets worse with time, especially if you miss the 4.5-hour mark for the clot-busting med, or the 24-hour mark for surgery. In summary, time is really brain when it comes to strokes. Sadly, this is something that we see every day, both as a final year neurology resident at Penn and a radiology resident at UCSF, both with neuroimaging and computational backgrounds. The reason is the inefficient time to intervention, with steps often done unnecessarily in series. When you add up the time it takes for an ambulance to arrive and assess the patient, transport to a stroke-capable hospital, for ER doctors to then intake, for neurology to assess, conduct a stroke scale, and finally, imaging and intervention planning, in total, it may take over 2 hours and cost hundreds of millions of neurons before a patient gets treated. However, the key piece is the neurologic assessment, which, if done earlier, can speed up the process. By implementing a stroke app early that can determine stroke severity, the ambulance could then link up with a stroke center and a neurologist to start planning the intervention en route. When the patient finally arrives, all you need is a quick CAT scan before intervention, thus saving time, brain cells, and lives. Our stroke app would use AR and AI-based visual recognition technology to conduct a stroke assessment, detecting facial droop, arm and leg weakness, and difficulty speaking. This effectively puts a neurologist in the palm of one's hand. After relaying this info to the nearest stroke-capable center, the ambulance can drive over as the hospital begins preparing for the stroke patient's arrival. When time is brain, our hope is that this app can put more time on the clock. We're excited to work with you.
Hi, welcome to CarePods, AirPods that care about your health. This is my idea to leverage the pre-existing sensors in these wireless earbuds to detect concussion. My name is David Wu, and I'm an MD PhD candidate at UCSF. Anyone can get a concussion. Every year, over 70 million people sustain a head injury, mostly from falls and car accidents. Unfortunately, even one concussion can cause long-term disability, but most people do not seek any medical care. If you do go to the emergency room, you're asked a set of questions. What's your name? What's today's date? Where are we? Right now, a questionnaire is our best diagnostic because brain scans miss 90% of concussions. The problem is, we don't know how much force was impacted to your head during the injury. It's not like people walk around with impact sensors on their head all the time. Well, not until 2017, when Apple introduced AirPods. Since then, they've sold over 100 million, each with built-in accelerometers that detect motion. I propose we use this accelerometer data to record and detect sudden forces experienced by your head, like in a concussion. If you're hit hard enough, the app will alert you to seek medical care. At the doctors, they'll replay an animation of the injury as well as the estimated impact force. And afterward, it'll monitor your recovery by asking questions about symptoms you may be having, like insomnia, fatigue, or impaired concentration. Now, when you're not wearing AirPods, this app can tap into other accelerometers in your devices, like in your iPhone or your Apple Watch. Ultimately, I envision this CarePods ecosystem to be integrated into iOS so that every pair of AirPods starts caring about your health right out of the box. I think it's a no-brainer because anyone can get a concussion, but no one should fall through the cracks. Thank you.
Hello, my name is Sharad Adwani. I'm an assistant professor of pediatrics at UCSF and a pediatric transplant hepatologist. I primarily care for children undergoing liver transplantation. I wanted to start by really highlighting how environmental and social factors influence our health. This is a map of New York City, and you can see here that residents just 6 subway stops away have a 9-year difference in life expectancy. This extends to pediatric liver transplant. We found that children living in socioeconomically deprived neighborhoods have an increased risk of graft failure and death after transplant. Well, there's more interest in learning about the specific social risks that influence these outcomes, and there are a variety of tools that assess for financial strain, housing, food insecurity, utilities, transportation challenges, and intimate partner violence. And one such tool is the AHC screening tool. So the question that we have and the problem we hope to solve with this app is to how can we seamlessly collect sensitive social risk data from patients and families without being intrusive and delivering information to the relevant stakeholders. And so what we propose is to develop an app that can screen patients and families for social risk factors and deliver that information to the relevant stakeholders, like community-based organizations, clinical team members, and transplant networks. This app for patients must be easy to use, non-intrusive, and adaptable. For the clinical care team, it must import data into the EHR, pull data from the EHR, and provide a dashboard view. And finally, for external stakeholders, it must integrate with some of our external transplant research networks, as well as with community-based organizations. Thank you, and I'm excited to work with you on it.
Hi, I'm Ryan Halverson. I'm an orthopedic surgery resident at UCSF, and this is Spinal Cap, an app-based approach to motion capture for the lower extremity and spine. Over half of Americans report at least one musculoskeletal condition. Many of these are due to lower back pain. These conditions affect patient biomechanics. The underlying movement patterns are diagnostic of pain severity, disease etiology, and things like patient response to treatment. However, full biomechanical analyses are rarely performed in clinic. This is because traditional motion capture is expensive, it's time intensive, and it requires trained personnel to perform. The sit-to-stand assessment is a simple functional test that is potentially discriminatory of chronic low back pain patients because it places large loads on the spine. Our lab has an existing data analysis pipeline, but we need easier methods for data collection. This is where Spinal Cap comes in. As patients perform the sit-to-stand assessment, they're recorded by a clinician using our app, and their data is exported into our existing data analysis pipeline, which allows us to compare them against other patients. Potential users include clinicians, physical therapists, and even patients themselves. This project will have three main components. The first is a user interface that's simple to be used in clinic and by patients at home. The second is the motion capture component. This will be done using Apple's ARKit API. Accuracy with this is very important. And finally, data management is essential as it will need to be exported and integrated with our existing data analysis pipeline. In the future, Spinal Cap will be able to assess other parts of the body, such as the lower extremity. It will enhance patient care by increasing the availability of biomechanical data. Finally, as more and more medicine moves online, especially during COVID-19, this will increase the capabilities of what can be done using telehealth. Thank you for listening.
Welcome to DermScan, the smart teledermatology platform. This is our idea to integrate 3D scanning, telemedicine, and machine learning in a single smartphone app to transform dermatology. I'm David Wu, an MD PhD candidate at UCSF. I'm teaming up with Dr. Wilson Liao, Professor and Vice Chair of Research for UCSF Dermatology. Skin disease accounts for a third of doctor visits. In the US alone, the burden of skin disease exceeds $75 billion annually. Patients with chronic conditions need frequent monitoring by dermatologists, but nearly 70% of US counties completely lack dermatologists. Teledermatology has the potential to overcome these barriers. For this to work, dermatologists must observe skin changes consistently over time, from tracking suspicious moles that may become cancer or assessing your skin's response to a new treatment. While the photos shown here are high quality, patient-submitted photos are extremely variable, with fuzzy photos being very commonplace. High-quality images can be achieved but require expensive medical imaging systems or time-consuming travel. Dr. Liao has patients who drive several hours to UCSF just for a single appointment. There's currently no teledermatology platform that's simple, high-quality, and cost-effective. We propose a smartphone app to monitor skin disease over time. It has three parts. First, an interface to scan your skin. To make this quantitative, we'll leverage 3D scanning tech to automatically map the skin onto a 3D model. Here's a free app I downloaded to show you that this could work. Second, a digital journal to track and view the skin changes over time. And third, long-term, we'll incorporate machine learning-driven analytics. This can provide smart alerts for patients and doctors on disease progression and also empower researchers with high-quality quantitative data. In the era of COVID, telehealth has become more crucial than ever. At UCSF, clinical trials are now on hold because of another viral surge. This critically needed teledermatology platform would be a game changer for doctors, researchers, and patients. We invite you to be part of the team that will revolutionize dermatology.
Hi everyone, my name is Evan and I'm currently an ophthalmology resident at UCSF. Today I'm excited to talk about our hackathon proposal called iSee, a phone application that can help patients visualize eye disease through augmented reality. Today more than ever, there is an increasing need for eye care. With rising rates of myopia, obesity, hypertension, and diabetes, more patients than ever are experiencing ocular sequelae of systemic disease. However, there is a wide variation in the severity of these diseases, and recognizing which symptoms are severe is key to receiving timely treatment. And ultimately, timely treatment can mean the difference between preserving vision and permanent vision loss. For example, when caught early, retinal tears can easily be lasered in clinic. However, if not treated in time, tears can lead to detachments, causing possible permanent vision loss and necessitating surgery and multiple follow-up clinic visits. For patients who have never experienced symptoms of serious eye disease, it can be difficult to convey exactly what they see or what we tell them to watch out for, these red flag symptoms. Things like flashes, floaters, and curtain across your vision are sort of hard to visualize. Our app, IC, would aim to build a library of the most common ocular symptoms that can be directly visualized via augmented reality. Having access to these examples will increase patients' awareness of conditions that require urgent care. For example, this is what patients see as normal vision in our application through augmented reality. In this example, we represent what an effect overlay would be on what they see through the camera so they can visualize what floaters look like. Our app would also allow patients to create their own visual reality from customizable building blocks of common visual phenomena, helping patients better communicate their visual symptoms with emergency and eye care providers. This can ultimately help aid in the timely triaging of potentially blinding eye conditions. These visual realities or maps could also serve as examples for other users to compare to and even guide future research about patient experiences of eye disease. Overall, this app can have an instantaneous impact on improving patient-doctor communication and prompting earlier vision-saving interventions. With your help, we can start saving vision today.
Okay, those were some really worthwhile proposal videos. I'm gonna share my screen again really quick, so 1 second. Okay, so now it's my pleasure to introduce Mark Malone from Apple. He's Enterprise Technologies Evangelist. He will present different development frameworks, and then we'll come back together for 1 minute to discuss how the breakout rooms will work. And then the last hour will be spent with you and the UCSF PI. So let me stop sharing. Mark, you can now share your screen.
Boom. Do you have me?
Yep.
Is it working?
See it. Thank you.
Okay, good. Well, so one thing, Derek, thank you for having me. This is a real honor to be part of. I guess it's the second biannual or whatever it is, iHackHealth event. So it's a real pleasure to be here. And I was saying earlier before everybody joined it that I put together a presentation of the various frameworks that we've got for our various devices. And after getting a look at these proposals here, it seems like there's a really nice overlap between some of the things that I'm going to discuss and then some of these projects that are there. And so without further ado, why don't I start really yammering on the content. So this is a series of frameworks that we've got for building health apps. And I'll just sort of say at the top line is there is a ton of functionality in our mobile devices. An iPhone, an Apple Watch, and AirPods, as you saw, there's a ton of technology. And a lot of times it's not thought of as technology that can be used for a purpose that's other than the one that we typically present. And so what I generally like to do is to sort of take people and say, hey, you're used to using these particular capabilities when you use your phone day in and day out. Did you know that you can use them for these other purposes as well? And so that's a lot sort of what the content is that I've got here. And so, I mean, it's probably fairly obvious to you folks in the virtual room here that the iPhone is a popular target for folks looking to build health-related solutions. And because Apple Watch has a lot of that same technology built into it from a health perspective, and frankly, even more because of the sensor capability, a combination of something that's an iPhone as well as a Apple Watch solution is kind of magical because you can really join together the best aspects of both devices. And both of these devices have a ton of capabilities, as I said, that's built into them. And it's not just sort of for sending messages to your friends. It's so much more than that. And a lot of these technologies are all about doing things in sort of a magical way and typically fun things. but they're also really nice, nerdy, data-rich sensors that we can use and contort to do what we want them to do for very unique solutions in the medical space. And so beneath the surface of all of the devices, they're packed with technology that powers just so many of the features that people are familiar with, right? So there's a microphone for making calls or talking to Siri. There's a light sensor for setting the screen brightness based on ambient light conditions. And of course, no iPhone is complete without a set of amazing cameras for making pictures, taking photos, uploading them to Facebook, Instagram, those types of things, or as pedestrian as video conferencing. There are a ton of radios in here as well. Typically used, most people think about sending voice or data over a cellular network or Bluetooth for connecting to your car or listening to music in your headphones. And of course, there's other positional type sensors that are in here and most commonly used for sort of where am I? What am I looking at? Typically presented in some sort of map view or something like that. But these sensors, as I say, they're not just built there for our internal applications, the things that ship on the device for them to use. The data that they generate is accessible to you as developers in its raw form. So you get raw access to the data coming off of these sensors, and you can do very interesting things with it. And so that data is rolled into high-level frameworks that we provide, that we collectively as a group call the iOS SDK. And so anybody that's building for our platform will use this iOS SDK, sort of dissect it into its constituent parts and use a particular framework that is relevant to the challenge at hand. And that's really sort of what this is all about. It's the combination of these high-level frameworks that get access to this hardware data that I hope will make it very easy for you to go and implement some of the solutions that I saw discussed today. Now, the iOS SDK groups sensor data and functionality into a series of sub-development kits that we call frameworks. They typically have like a kit ending to it, like Health Kit or Vision Kit or Care Kit, those types of things. There are a set of frameworks that you drop into your application when you're doing development that provide very discrete capabilities. So when you're thinking about the app you'd like to create, it's really all about like determining which framework provides the easiest path to the particular data that you need in order to implement a particular feature. And so I'll walk through a few of those here just to give you an example. The Vision framework is one that will be used quite a bit in the use cases that we've seen here today. And it takes image data and processes it in a number of ways. And one of the most pedestrian ways is barcode scanning, for example. When it comes to barcode scanning, it supports, with just the camera and the Vision framework, a ton of the different barcodes that you will run into in your daily life, not just scanning the barcode on a can of soup, but also very medical specific formats as well, like micro QR that you would see on specimen tubes or prescription bottles, code 39, 128, data metric, those types of codes, as well as the standard consumer type code. And since it's built in, you don't need to use a third-party framework in order to go and do that. And there's a lot of third-party frameworks that do code scanning, but some folks might not know that that's already there in the Vision framework and ready for you to take advantage of. But beyond that, beyond simple barcode scanning, the Vision framework can also allow you to take data coming from images and process it in a number of ways that I think are just shy of magical. And like, for example, providing feature detection. And feature detection in the Vision framework, basically at its most basic, takes pixel information from an image and provides you details about the facial landmarks. And it not only detects these landmarks that they exist, like, oh, eyes, nose, mouth, I'm looking at a face, but gives you positional information, highly accurate positional information for each one of these facial landmarks. So you could calculate distance perhaps between them to check for abnormalities that may indicate a stroke or make other determinations based on historical change of relative position. Maybe you're taking a photo of yourself using your app on a regular basis, and you can see trends over time as these areas of your face tend to shift and move, not only with age, but perhaps as a result of medical situations that require intervention. These measurements can be performed on snapshots, so somebody can hold the device in front of them and have it determine these characteristics. You can also upload a photo, and it can also do it in real time as well. So if somebody has a video of themselves, perhaps that they captured, or you've captured a video of somebody in your family, perhaps you're a caregiver, you can track those items as well, just in a video file, just by using the vision framework. So the vision framework is for you if you're doing any of this sort of facial recognition, feature detection piece, and we have a couple of the projects that will use it. But the vision framework is rich and can detect other human features as well, and we'll be using those in a couple as well, including pose detection. And poses are basically hand pose movements, right? So not only can we detect a face and its various landmarks, but hand pose detection provides you the landmarks for the phalanges, joints, the wrist. Again, this is super useful if you need to make hand mobility measurements to compare against a normal or desired baseline, or even convert sign language signs to text, for example. And it's not just hands. The vision framework provides pose detection for the entire body as well. And so it provides you the position of whole body landmarks, such as the eyes, nose, ears, and neck, shoulders, elbows, wrists, hips, knees, ankles. Basically, we can give you a dot for any of those points of articulation that you have on your body. And like facial feature detection, it works with snapshots, movie captures, and of course, in real time as well. So that was a brief, fast review of the vision framework, and I've only touched on a few of the interesting ways that you can use it to work with image data in your app. So definitely take a look at that if you haven't. Vision framework. It's a great place to start. Another incredibly useful framework, especially when it comes to sort of raw motion data that I know a few of these projects want to have access to as well, is one called Core Motion. And Core Motion combines information from the gyroscope on all these devices. There's an accelerometer on there. We can detect gravity, all types of motion detection is available on these platforms, and it's through this Core Motion framework that you, when you're building out your app, get access to it. So motion tracking provides real-time measurements of a device in 3 dimensions, pretty straightforward, and based on that motion of the device. So if the device is on your wrist, it's in your hand, or if it's in your pocket, it's moving, and it's aware of the fact that it's moving through space and time, frankly, as well. And it'll give you a ton of timestamp data that you can use to do very interesting things with. Now, so the raw information, when you look at it, isn't very interesting, but it's when you start actually visualizing the data that you will see trends and predictable spikes in graphs that you can convert to predictable motions or those types of things. A given chart will repeat itself for a given repeated action. And we do this all the time. We use other frameworks on our platform to use this same motion data to determine things like steps or the distance that somebody has moved, or to go up a flight of stairs, or determine the pace, what's the distance between their various steps and how fast they're actually taking those. So all of those things are available based on the raw data of these motion sensors, but there's also high-level APIs that you can call to get the number of steps, get the distance that somebody has moved, how many steps they've traversed, as well as pace and cadence as well. Now, this motion measurement isn't just available on iPhone. As you've seen in some of these pitches, Apple Watch has the same sort of sensors to determine gravity, acceleration, rotation. And this is super useful to use when your iPhone isn't around, or when you're trying to accurately track upper body movement, something associated with the arms, or where a phone in your pocket isn't necessarily really representative of the type of movements that an accelerometer on your wrist would be best to take advantage of. And so you can use this for, again, hand gestures, perhaps. We use it for sports activities for sure. You can use it to track progress of all sorts, perhaps for recovery from surgery or other physically debilitating events. And so Watch has this motion capability. And of course, the AirPods and the AirPods Pro Max have it as well. And these accelerometers are on there. You might be wondering, why are they on there? Well, one of the really most interesting implementations of having this on there is our support for spatial audio. And so if you have an AirPod Pro, if you have an AirPod Pro Max, you pop these in and you hit play on your music. As you rotate your head around, the sound will appear to be emanating from the direction that the device is playing the music from. And so as you turn to your right, you'll hear more through your right ear. As you turn to your left, you'll hear more through that. And so it's a really nice way to spatially experience audio. Well, again, you have access to these motion sensors, and you can take advantage of them in interesting ways because they provide the same XYZ data out of them. And while we might use it to go and place audio around you, you can use it for perhaps tracking tremors or posture or flexibility, perhaps after a neck injury, those types of things where it would be a very sort of head-centric type movement that you want to track. So if your app needs to track and process motion data, then the Core Motion framework is a great place to begin your journey. Again, it's on iPhone, it's on Apple Watch, and it's on the headphone as well. And all of these APIs are available, or all of this data is available through the Core Motion framework. And the Core Motion framework, when it gives you the data, it tells you which particular device it came from. So somebody might have headphones on, a watch on, as well as a phone, and you can say, I want the motion data from the phone, or give you the data from the watch. You get to cherry pick the ones that are most relevant to you. Now, if you're thinking, okay, we've got this raw data, and boy, looking at this chart of motion information, it can be a fairly daunting task on how to process it. If you're scratching your head like, okay, what's the best way to go and maybe map this data, changes in this data to actual physical activities that you want to go and track? Well, as you might expect, interpreting this data in your app in real time is a task that's best left to, of course, machine learning. And that's where CoreML, the CoreML framework, is another one that's worth discussing as part of this romp through the frameworks. And you can use CoreML to leverage machine learning models in your app to process that motion data. And so it allows your app to interpret the data in arbitrary ways, not just ways that Apple thought it was interesting, but those that you defined as interesting as well. And so it's really a great way to turn your app into a smart app. It's an intelligent app that's armed with the smarts to interpret the motion data in a manner that makes most sense to that particular project that you folks are working on at a given time. Now, building your own model for CoreML is easy. I know it's the Apple guy saying it's easy, but it really is. It's very simple to put on an Apple Watch, put an iPhone in your pocket or hold it in your hand, place it anywhere you'd like to track motion from, hook into the Core Motion framework, and just grab the data in over a particular time frame that somebody is doing something. And in this example, it's jumping jacks, right? So say, okay, start your jumping jacks, start recording this data. And as all you need to do is you save it in a file that's comma delimited in a text file, do repeated runs of that. So build up a set of these text files. And then you place these files in a folder on your Mac, and you give it a title of the action that it is basically a recording of, right? And so it's jumping jacks. Each one of these is a data file that I recorded while doing jumping jacks, popped it in there, And then we have a tool that's built into the Xcode application that you can download from the App Store. And it's called CreateML. And so you drop this folder into the CreateML developer tool, and it will generate a machine learning model for you. It'll basically take all of that data and create an action classifier model for you, which is pretty sweet, right? So then you have your application, you drop this model into your application, you grab the motion data while somebody is doing something, and rather than just writing it to a file, you pass it on to the machine learning model that you dropped into your app, and it will give you feedback. It'll say, hey, the prediction is high that this person that is either holding the device or has a watch on their wrist is performing a particular action at a given time. It's like I said, it's pretty sweet and pretty straightforward to do. Now, learning institutions have all sorts of technologies that they use for machine learning. And so if you already have machine learning models that have been built using various technologies, various ways, various formats, we have an open source project called CoreML Tools, and it's a Python-based tool. And basically you point it to the model that you've got, be it in Keras or TensorFlow or whatever, run it through the Python CoreML tool, and it'll pop out one of these same sort of models that the CreateML tool does as well. And one of the really interesting things is, because it's Python, it means that you can come up with a cloud-based application as well, where perhaps you're taking a lot of the learnings that you're gathering from these devices, pushing it up to a server and creating a compendium of data on the fly that's based on really broad representation of people that are using your application. It's Python. It can go and generate based on a wide set of data, download a new model over the air, and just this new model can be used immediately in the app that's already distributed. You don't need to recompile or redistribute the app, but this model is available in your app, and it's just a great way to get your model smarter and smarter and smarter. As you share the learnings back up to a cloud, you've created a bigger compendium of data that you can generate better and better models. Okay, so that was a quick overview of the CoreML framework. And I hope it makes it pretty clear how quickly you can combine the tabular motion data with machine learning in your app. But it's important to keep in mind that CoreML framework can classify a lot more information than just tabular data. It can take audio information as well. You can just drop an audio file into a folder and say, this is the sound of a dog barking. This is a sound of a pneumonic cough. This is the sound of whatever it is. If you collect enough audio samples, you can go and create a classifier so that when within your application, you flip on the mic, you have somebody execute a particular thing, or you record a particular sound, you can send it to CoreML and have it give you feedback on what that particular thing. So audio, image, video, any of that, where you can get representative samples of that type of binary information, feed it to CoreML and get an intelligent model out. Okay, 3 frameworks. We have tons of others. We've got office hours where we can talk about these ad nauseum as well. So there's probably 5, 10 other frameworks that might be interesting to you folks as you're building out your apps. But from a generalized framework perspective, I'll leave these here and sort of move over to just sort of to wrap it up with 3 very health specific frameworks that I think you'll find very interesting as well. And they're called Health Kit, Care Kit, and Research Kit. Now, these frameworks are focused on providing high-level access to health data and pre-built user flows and screens that are common in health and fitness-related applications. So I'll go through each one of these in a bit of detail and just start with Health Kit. So Health Kit is built into every iPhone that we ship, and at its most basic, Health Kit provides the capability to allow Apple Watch, iPhone, and your health app to read and write health data that is stored in a centralized health database called the Health Store. The Health Store database supports over 200 types of granular health information. And of course, it's all got to be stored in a standardized format. So no matter who is reading or writing the data, when you ask for caffeine intake, you're getting it in a manner that is going to be consistent across all of the different applications that might use it. Heart rate information, blood alcohol, no matter what it is, it's using an industry standard implementation of those particular data types. And so the quality of the data is guaranteed to be consistent across all the different use cases. So some of this data, while available, much like that motion sensor information is available in its raw form, we also roll up this raw data in and use it in combination with some of the motion sensors to provide some built-in intelligence that we pop right into the health database as well that you have access to in your app. And we call these mobility metrics. And so these mobility metrics are determined by the same motion sensors that I mentioned early. And these are basically traditional mobility capabilities tests and values that would typically be garnered by somebody walking into a hospital or a doctor's office and running through a series of tests. These things, because these devices are in your pocket or on your wrist, it means we can, as researchers and clinicians, we can take advantage of information that's been collected over a long haul. And so just by having an iPhone in their pocket or handbag, anyone, sort of anywhere near the center of body, HealthKit can provide you as an app developer key metrics such as walking speed, that's how fast a person travels over ground, right? Step length, is a person taking short or cautious steps, or maybe long confident strides, right? Those are good indicators of mobility. Double support time, a standard, and that's the percentage of time during a walk when both feet are in contact with the ground, as well as walking asymmetry, the percentage of time that steps on one foot are faster or slower than steps on the other foot. And you can see that would be easily valuable to determine if somebody is limping or if their gait has evolved over time. And when that particular gait change has occurred is part of the information that you would get back as well. Now, mobility metrics that are gained from the watch that are unique, of course, are provided as well. Whether they've got the phone or they've got Apple Watch, we can determine if the speed they're going up a flight of stairs, for example. That's a good indication of overall health, especially changes in that performance if it's a regular set of stairs that they would take over the course of their day-to-day existence. Apple Watches uses activity clues that happen naturally over the course of a week to estimate what a person would score on a 6-minute walk test as well. And VO2 Max is available and accurately supports people with lower levels of fitness. Instead of requiring like run level effort, Apple Watch can predict VO2 Max using slower walking speeds as well. So it's not just about fitness VO2 Max. People that just wear the watch on a regular basis were able to determine VO2 Max at that particular cadence as well. And of course, if the wearer is periodically checking their ECG, those results are stored in the health store as well, and so you have access to them. There are also various notifications that are sent off when things go awry. So if there was an AFib notification or something like that, you can register your app to be notified as well, so that if you have a caregiver app or something like that, and you need to fire off some messages to other people in the care group that something has happened, you have access to that capability, which is really useful. And it's great for good outcomes, and of course negative outcomes as well. Those are really the ones that you really want to be aware of within your application. So just a quick mention of privacy is super important here. You have access to a lot of health information, and HealthKit provides it. Basically gives you pretty much unfettered access to a lot of this information that's stored in the health store. But the owner of the device, the owner of that health data, is in the middle of that conversation, just so you know. So the owner of the information needs to be aware of which data at a very granular layer is being processed, is being accessed. And basically, if you haven't seen it before, there's a very granular permission screen that's presented to the patient or end user before you access sample information that is stored in the database. So one of the things that you want to be aware of is that by default, nobody has any access to this health information. It's definitely off availability for any sort of application when the device is locked. When the device is unlocked, then applications that have been provided explicit permission then have access to those explicit data types that they've given permission to. And hopefully you've seen this dialogue before, but this is the permission request that we present anytime you as a developer want to go and first time access this type of information. It's a system provided UI, but as you see, let me give you a spec of code here, getting access to the health information is as easy as just requesting authorization. You basically pass in the types that you want access to, and then the operating system on the device will pop up the screen. The patient will slide on, hopefully turn on all those things that you need access to. And there's also some strings that you provide that say, hey, this is why I need this particular information. This is your chance to convince the end user that this information is relevant and important to be used in your particular application. So it's not difficult to implement. You basically build up a set of the types of data you'd like to read, and then you pass that to a function that automatically displays that request for permission that you showed. And then when you query for the device, you'll use specific queries that are really the queries that are based on the type of action that you want to do on that data. Now, of course, you get a very discrete level access to data, so you can sample for a very specific sample. That's just basically a sample query, get very staccato results. But there's all sorts of series as well. You can ask for a range of samples over time. You can also ask for statistics to be gathered, so you don't have to do that, right? So we will do that. If you run a statistics query over a given time on a given data type, we'll give you back the stats on it. It means you don't have to request all that data, do the math, and then present it yourself. We'll take care of that just by using the right query. And again, when we get into office hours, we'll talk through the ones that will be appropriate for the given use case that you want to do. Now, here's an example of what.
I'm sorry to interrupt you. Can I ask one quick question we have from the group here?
Sure.
We're saying, so how can we actually access these toolkits is the first question. I'm sure you'll send the URL for that. And then the other is, are these frameworks able to be used to develop apps on non-Apple devices? And I think we know the answer to that as well.
Yeah, so all of the frameworks are built into the iOS SDK. The iOS SDK is built into the iPhone, the way you have access to it. The tools, the frameworks that I mentioned that access the iOS SDK are built into the Xcode tool. The Xcode tool is basically a project management and application development suite of tools that we provide for free. They run on a Mac. While they give you general text editing capabilities, they are designed for building applications that run on Apple devices. The frameworks that I've talked through, these are frameworks that we've built to integrate with our hardware. So these frameworks will not provide access to accelerometer on an Android phone, for example. They provide very specific access to device-specific capability. So the Xcode tool is all you would need. You need a Mac. You would go to the App Store on the Mac and you download a free application called Xcode. Xcode, it's a pretty big download, so you might not want to do it while you're on a video call because it might slow things down. But once you go and launch Xcode, you've got the complete development environment to build any type of application, be it for Apple Watch, iPhone, for AirPods, for Apple TV, anything that Apple makes, you can use the toolkit to go and build.
Okay, great, thanks. And do you think we'll be able to wrap up here soon so we can split up into our breakout rooms? You just finishing
Absolutely.
up here? Okay, thanks.
Absolutely. Yep.
Appreciate it.
Speed it up. I got it. Okay, so here's just a quick example for the nerds in the room of how you would retrieve step data. Specify the step, the duration of the samples, whether you want to limit the number of records, have it sorted, then execute the results. Really straightforward. If you want to have your app notified every time there's new data of a given type, you can register for notifications. So every time somebody goes for a run, for example, you can have your app notified. You'll start receiving updates every time something comes. And of course, as I said, if you want to statistically summarize things in a chart way, you can ask for the information in a way that makes it really easy to go and roll it up. So these queries that I mentioned, they work across the bulk of the samples, but there's one other that I wanted to just sort of throw out there, as well as we do have health records as well. So if somebody has taken their phone, connected with their EMR, then they have an opportunity to download all of their health records onto their device. And so this is just an example of connecting with Kaiser as a hospital. I'm able to pull down all my vaccinations, all of my tests results, those types of things. You as an app developer have access to that same sort of information. So if it makes sense to dovetail sample information with clinical results as well, past history, those types of things, again, it's a query that you make to the database. Now that all of that data is in FHIR format, which may or may not mean something to you. It does in the medical field. It might seem a little daunting, but we've got an open source framework to parse FHIR formatted medical information and create basically objects that will resonate with somebody that's ever created an application for one of our devices, and that's the FHIR models. Two other things I'll just talk about real quick is CareKit and ResearchKit. CareKit and ResearchKit are open source frameworks. You can go to researchandcare.org. They're provided freely by Apple as open source projects. There's a lot of folks that participate in these, and you'll get a great overview of what each project provides. If you go there, some sample applications that use ResearchKit, for example, you can download them just to get a feel for what they're like. And you can see some good representative uses of CareKit as well. A lot of folks will combine these particular applications these particular frameworks to create a given application. And typically when they do, they take advantage of sort of these three main buckets that both of these frameworks and just about any medical app need, which is an onboarding flow, some sort of tasks that happen within the application, and then some active tasks as well. You want people to go and do some sort of actions, those types of things. And so to support onboarding, these projects give you pre-created screens and flow logic that you can use to support any of those processes, often required by somebody using your app, including the ability to support arbitrary questions, assess eligibility, prompts for consent, as well as collecting signatures. And so here's just a quick example flow of being asked to provide consent. Screen comes up. Again, these screens are already built. There's a set of questions or bullets that you can provide to get feedback. All the legal detail is provided, and then a field is there for you to go and use your finger to sign your name. The idea is that these screens are already created. You download them, you drop them in your application, and you take the text that's ipsilorum right now and convert it to something that is relevant to your particular implementation. And we've provided the placeholders for all that and the way to go and hook them together. So a really fast, easy way to go and build out screens, even for things like notifications, asking permissions, those types of things, notifications for health sample types, receiving notifications for like alerts, those types of things, as well as access to motion data as well. So onboarding flows already built, part of those open source frameworks. Take a look at them. Tasks as well. Tasks are typically things like surveys. You want to have people walk through a questionnaire. How are you doing today? Or tell me this, that, and the other. These tasks are basically ways to go and format or collect answers to arbitrary questions that you'll come up with as part of your research application or your solution. And so just a quick sample of a flow here is like, oh, how are you feeling? Or tell me, something about yourself. Well, we've got these little sliders that we pre-built, you drop into your application. You can use these scale tasks to go and collect these numeric values. They look like Apple controls because they are Apple controls. And so the end users will automatically know how to interact with these things as well. The last one I'll leave you with is active tasks. And as the name implies, it's all about doing something actively. We've got one project for sure that was vision-based. So we have some vision tests that are in here. We have a couple projects that were mobility-based as well. And we've got some mobility active tasks in. Again, they're pre-written. You drop them into your application. They access the frameworks that I talked about earlier, and you have high-level access to these types of active tasks. And here's one basically for a range of motion task that steps the user through a task just by using audio clues. So the voice prompts the user each step through the way because they're not necessarily looking at the device as they're going through this range of motion study.
Place your device on your left knee. Tap the screen and extend your left knee as far as you can. Touch anywhere to continue. When you are done, return your left knee to the start position, then tap anywhere.
So it's a complete walkthrough of how to go and collect this motion data from somebody that's just holding a phone to their knee. It provides all the voice feedback, those types of things. And then you, within your app, have access to that data. And then you can determine if that range of motion is something that makes sense or not. So that was a quick romp through those three frameworks. As I said, researchandcare.org is the place to go. And with that, it's Health Kit, Care Kit, Research Kit. Those are going to be the core ones from a medical perspective that you'll want to focus on. And of course, don't forget that the entire iOS SDK is there for you to access the raw information and those other things that aren't necessarily provided as part of these other frameworks. Really think outside of the box for those. So with that, I'll leave it to anybody that has other questions. Derek, if you want to prompt me with some. Otherwise, we've got office hours on Friday. And I'll just shoot you my email here, mgm@apple.com. If anything comes up over the course of your travels through our frameworks and a question pops up, feel free to either save it for office hours or shoot me an email and I'll get back to you as soon as I can. That's me.
Thank you, Mark. That was great. I want to, we popped up some of the questions we had already. I think everyone's really appreciative of the breakdown. I want to make sure we have time for the groups to meet. So I want to make sure that we can see the last slide here. I want to show, and then we'll give some instructions for the breakout rooms. So tips for success on this challenge. Remember, you're going to employ design thinking. You're going to iterate, especially with your PI. Working as a team, we know that there were some comments in the chat that 10 people and even more with the wait list can be a really large group. But that's why I think delegating different subtasks of the project can be really helpful. If you didn't see in the chat, we did mention that if you are on a wait list, that's perfectly fine to still join the group that you're on the wait list for. But again, you can only pick one proposal. Develop a work plan, even if you deviate from it. So this is why meeting with your PI is going to be so helpful. Start early and meet as often as you possibly can. Use the collaboration tools and work as a team. Leverage the different expertise. If you go in the spreadsheet and see everyone's experience with programming, it's pretty remarkable. So utilize what you're best at and please have fun. We really hope you enjoy this experience. So we're now gonna open up the breakout rooms, but Nate, before you do that, or it's okay that you did, but before you jump into the one, you're gonna join the group that you're a part of. The PIs will join them as well. Please stick around and meet one another. There are a couple of groups where the PIs were unfortunately not able to be here today. So one of us on the Appathon team will join the group to give you some information and next steps of how you can contact the group. So again, thank you, Mark, for the presentation. That was really helpful. We'll be around and you'll see people on the team will be joining the group. So now please join the proposal breakout room that you signed up for, and good luck with your programming.
Great, thanks, Eric. Folks should be able to join the breakout rooms of their desire based on proposal. And if you are not, based off what kind of Zoom you have, feel free to write in the chat which proposal you'd like to go in, and then one of the hosts can whisk you there.
Oh, wow.
It's looking like no one can join. It says broadcast message to all. No.
Let me try closing it and opening it up again.
There we go. I see them now.
All right. Please try again. See if you can join the room that you would like to by yourself without us doing
I
that.
see them now. People are joining. Yep.
Excellent.
Thanks, everybody, for your patience.
And a few of us will stick around in the main session. I'll volunteer to do that right now in case there are any technical issues or anything that we can help overall with the organization.
So I'm gonna go to group 4. I think Maddie's gonna go to group 3 because those are the 2 PIs that we know couldn't be here. So I'll meet with that group, give them some information. If you all want to split up, I'll bounce around to each group too, just individually, throughout if you want to as well, to maybe help answer questions. Julie, I don't know if there's anything you want to talk about specifically.
Yeah, and I can stay here if people come back to the main room and need help. Mark, I know people would love if you bounced into the various rooms if you have time.
Sure. Yeah. I was just wondering, like, should I hang up? What's the next step? Yeah.
I'm going to join group 4 now. So I'll come back in a minute, everybody.
Thanks, Derek.
I guess I got to